Hello, Math 2. This is Mrs. Bricky, and this video is for Unit 7, Lesson 3. We're going to be graphing circles today. So we worked with circles a lot in Unit 6. Just as a reminder, a circle is a set of all points that are a fixed distance away from the center, and that fixed distance is called the radius. And we also had reviewed last unit the circumference of a circle, which is that perimeter outside edge of the circle. And the formula for that is C circumference is equal to 2 pi times the radius. And then area of a circle, which is the space that it occupies, is pi r squared. Today we're going to learn about the equation for a circle and how to graph them on a coordinate plane. So the way that we write the equation for a circle is actually based on triangles. It's sort of the Pythagorean theorem. So we know that that fixed distance away from the center stays the same. That's going to be the hypotenuse of the right triangle that you can see there. And every single point on the edge of the circle, every single ordered pair x and y, we can think about the x and the y as the legs of that right triangle. So if we fill those different variables and the 5 in this case into our Pythagorean theorem, we have x squared plus y squared is equal to 5 squared. Now, because 5 is a constant, we usually in the circle equation would not see a 5 squared. We would usually see the number 25. So this is the equation of a circle with a radius of 5 that happens to have its center located at the origin. So for different sizes of circles, if we have a bigger circle, this number right here will be different. It just depends on how big the circle is. But this definitely is a circle that is centered at the origin. So more generally, if we have just a radius of r, our equation just looks like x squared plus y squared is equal to r squared. So whatever that radius is, however small or big the circle is, we'll see that reflected over here on the right side of that equation. So if we had the equation x squared plus y squared is equal to 16, we know that that's going to be a circle that is centered at the origin. So we'll mark the origin centered just to help us get that circle placed correctly. Now, technically, the center is not part of the circle. We're just using that as a reference point to get the circle graphed. Now, the number here that you see at the end, remember that is not the radius. That is the radius squared. So we have to think about what number do we square to get 16. Well, 16 is the same as the number 4 squared. So our radius of our circle is 4. So the way that we're going to graph the circle is we're going to start at that center at the origin, and we're going to look at 4 to the left and 4 to the right. So we've got these 2 points, and then we're going to count 4 up and 4 down. And in theory, we could count 4 in any direction, but it's difficult to count it, in these other weird directions. The 4 directions that are very easy to count a distance of 4 are the left, the right, the up, and the down. So we usually just mark those 4 points, and then we kind of sketch that circle in as best we can. See, I can't do it very well. Oh, I have a tool. Watch, I can do a perfect circle. There we go. Hey, I was pretty close. Anyway, we do totally understand that when you're sketching these by hand, they might not be perfectly circular. Try to make sure that you don't draw a diamond. Try to make it rounded a bit. But other than that, we're going to be pretty understanding if your circles are not 100% perfect circles. So not all circles are centered at the origin, and that's okay. There's no problem there. The equation does get a teeny bit more complicated when the center is not at the origin, but it's nothing you can't handle. What we want to think about is that the legs on the triangle, or if we're constructing the general equation here, the legs of the triangle end up being x minus the coordinate, the x coordinate of the center, and y minus the y coordinate of the center. So the equation looks a lot the same. It's still based on the Pythagorean theorem. It's just that we have these little transformations with the y and the x. And that transformation is just shifting the center away from the origin. So when we see a more complicated circle equation like this one, we can still identify by looking at the equation the location of the center, and we can of course use that constant at the end to figure out the radius. Just make sure that you remember that this number that you see, if you see a 25, that means the radius is 5. If you see a 9, that means the radius is 3. So you either need to think about what number squared gives me this constant, or if you have a hard time thinking about it directly, you can use a square root to get the radius. So you would take the square root of that number, whatever it is. So we'll see some examples of that. All right, so our first circle that we're going to graph is the circle quantity x minus 2 squared plus the quantity y plus 4 squared is equal to 9. So looking at that equation, you can notice that the center is located at 2, -4. With circles, we see a sign change with both the x and y coordinate. So when it's in the grouping like this, with its variable, you're going to see that sign change happening. So if we see an x minus 2, that means the x coordinate of the center is positive 2. If we see a y plus 4 here in this second term, we know that the y coordinate of the center is -4. The radius squared is 9, so you can either think about what number do I square to get 9, or you can take the square root of 9 in your calculator to get that answer if you aren't sure what it is. So we're going to start graphing this circle by marking the center. 2, -4 is right here, so that's our center. And then we're going to count out 3 units in each direction, both left and right, both up and down. And once you have those 4 edge points marked, you can just draw your best circle that you can. I'm sure you'll have nice ones. Okay, so we're going to just practice identifying the center and the radius on a couple of equations without graphing them, and then we'll do a couple more graphs. So x minus 2 plus squared plus y plus 3 squared is equal to 49. So that center is at 2, -3. Again, we see a sign change. When we look at the equation, we see a -2 because it's an x minus 2. We know the center's x coordinate is 2. We see a y plus 3 in the equation, so we know that the center's y coordinate is -3. And then the radius, you can think about what number squared gives me 49, or you can do the square root of 49, whichever one works better for your brain. And so we get that the radius is 7. Okay, next one, we've got an x plus 4 squared plus a y squared, and that is equal to 100. So the center of this one, well, we can see an x plus 4, so we know that the x coordinate of the center is -4, but the y is by itself. That's the same as having like a y minus 0 or a y plus 0, so the y coordinate of the center is 0. And then the radius squared is 100. So either think about what number do I square to get 100, and that's your radius, or you can use the square root button in your calculator. So this one has a radius of 10. Okay, last one to practice finding center and radius. If we have the equation x plus 1 squared plus y minus 5 squared is equal to 20, let's see, our center will be at -1, +5. And then for the radius, it might be tricky for you to think about what number do I square to get 20. because it is not a whole number. So we're going to actually just all use the square root to get this radius. The square root of 20 is 2 root 5. So that's the exact radius of the circle. We will not have you graph a circle like this that has this irrational radius, but certainly a circle could be that size. And if we did need to graph it, we would just think about what's that approximate decimal value. And so we would kind of just be eyeballing it from there. And so this one, the radius is around 4.5. It's pretty close. But again, we won't have you graph one that has a radius like that. Okay. All right, let's graph this circle, and then we'll also connect back to domain and range. So the center of this circle is at 2, 0. So we see an x minus 2 in the equation. That means our center's x coordinate is 2. The y squared is, just by itself, so that's a 0 coordinate in the y direction. So our center is here at the point 2, 0. The radius of the circle is going to be 9, because 9 squared gives me 81, or we can think of it as the square root of 81, which is 9, however you like. Okay, so we've got to count 9. That's a long way. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we got to go back 9. And down 9. Okay, so this is a big circle, and I know I'm going to not draw that very well on my tablet, so I'll just go with my tool. There you go. Beautiful circle. Okay, so we are now going to do the domain and range of this circle. So domain, remember, is the x values, and we think of the domain from the left to the right. So the domain of this function, well, the farthest to the left is right here at -7, and that's part of the circle. Like, we literally marked that point. So it's going to be a bracket with a -7. And that circle covers the entire coordinate plane all the way over to right here at the 11. And again, we marked that as a point on the circle, so it is included. So our domain is from -7 to 11. For the range, that is the y values. And remember that we always want to report our range from the lower or the lowest to the highest values. For a circle, or for this circle, the lowest value was that -9. And again, I'm going to include that because we marked that as part of our circle. And the range covers all the way up to +9. And again, I'm going to use a bracket on that because that is a point on the circle, so we do want to include it. So our range is from -9 up to 9, including both. Okay. Let's graph a couple more. -1, -3 is the center of this circle. This one, radius squared is 1, but the square root of 1 is just 1. 1 squared is 1, so the radius is also 1. This is a little itty-bitty, teeny-tiny circle. The domain of this circle will be -2 to 0. Now that 0 sometimes is tricky. It's really tempting to put a 3 there, but 3 is a y value, and for domain, we are using x values. We're basically saying that circle is occupying from -2 to 0 in the x direction. The range is going to use the -2 and the -4 down here. So our range is from, we want to do the lowest up to the highest. So -4 to -2. Okay, next circle. The center, this x is by itself with that power 2, so that's a 0, +1. So here's my that is not the right point. 0, +1 is right here. And our radius squared is 25, so that means our radius is 5. So I'm going to count 5 to the right. I'm going to count up 5, 1, 2, 3, 4, 5, back 5, and down 5 to get my circle. Ooh, that's not my best circle ever. Okay, domain of this circle from -5 to 5. So again, for domain, I'm thinking about the x values. So we can see that this circle is occupying this -5 to 5 region of the coordinate plane. And for the range, I'm looking at those y values. The lowest is -4 and the highest is 6. Okay, if you're doing this at home because you missed class, you might want to do those first 4 practice problems and pause the video. Okay, so now we're just going to do the reverse. If I give you a description of the circle, can you write its equation? Well, remember our base equation looks like this. So our goal is to fill in the numbers h and k from the center, and then we want to put a number at the end as well. So I would say that sometimes the trickiest thing here is to remember to get the powers with each of those terms at the beginning. And I try to remind myself, oh, I'm doing the Pythagorean theorem. Something squared plus something squared equals something squared. So that helps me. So our first term is going to be an x minus 1 squared. So we're subbing in, this 1 into that spot. And then a plus. Try to remember to do y for that second. This will be a y minus 2. Again, just using the y coordinate of the center there. And we need a power of 2. So there's my a squared plus b squared, and it's equal to c squared. Now, in the equation, we don't want you to write a 4 squared. We want you to simplify it, so we want to write a 16 there because 4 squared is 16. We do want to make sure we square it, so we don't want to put a 4 there, but you should simplify it to be 16. Okay, let's try another one. This one has a center at -3, 4, and the diameter is 16. Well, if the diameter is 16, that means the radius is 8. So in our equation, when we have the radius squared, it's going to be 64. So our equation will look like x plus 3 squared. We'll have a y minus 4 squared. Don't forget the powers. And then that's going to be equal to 64. Again, 64 because if the diameter is 16, then the radius is 8, and 8 squared is 64. Okay, so this is the same, except instead of giving you sort of a verbal description of the circle by telling you the center and the radius, I'm going to show you a picture of the circle. For a lot of people, especially if you find this difficult, you want to write down the center. So look at the graph, write down the location of the center, look at the graph, count the radius, 1, 2, 3, and then from there you can fill it into the equation. It isn't uncommon to make an error if you're going straight from graph to equation. A lot of people can do that, and it's okay to do that, but if you need to, take a minute to write down the information, and that will help. That might help you avoid errors if you are finding it difficult. So we've got an x plus 2 squared plus a y minus 2 squared, and it's equal to 9. Sometimes students ask me if that will ever be a minus. For a circle, it will not be a minus in the center. It will always be a plus. And again, that's because we are really just using the Pythagorean theorem to write this equation. So we're always going to see a plus there. There's another graph shape that does use a minus, but you will not be studying that shape this year, so you don't need to worry about that. Okay, this circle has a center at 1, 2, and the radius, if I count that out, 1, 2, 3, 4, the radius is 4. That means in the equation, I'm going to see the number 16. So our equation looks like x minus 1, we do our power of 2, plus y minus 2 with a power of 2, and that's going to be equal to the radius squared, which is 16. Okay, I think this is our last problem. Yep. Use a description of the circle to sketch its graph and then write its equation and give the domain and range. So we have a circle that is centered at the point -2, -3, and it has a diameter of 10, which means that the radius is 5. So 5, 1, 2, 3, 4, 5. We're going to go up 5. We're going to go back 5, and we're going to go down 5. So here's our circle. So we want to write the equation and give its domain and range. Well, the equation is going to be, wow, not x plus y, x plus 2 squared plus y plus 3 squared is equal to, and our radius was 5, so in the equation we're going to see 5 squared, which is 25. The domain of this circle is -7 to 3, and the range of this circle ranges from the lowest up to the highest, so -8 to 2. Okay, that's it for circles. The bottom of your practice page has you work on writing equations, and then on the back of that assignment, it's actually mixed practice, so it's going to have absolute value functions, it's going to have some quadratic parabolas, and some lines. So that's a great chance to make sure that you are sort of getting everything into your brain, and we'll be having the review and test soon. If you have any questions, let me or your math teacher know. Thanks a lot.